Okay, now let's actually try creating a program somewhat from scratch and actually modify something in assembly. So if I take my original test program here, I'm actually going to strip it all the way back. I'm not going to call any functions, and the only thing I'm going to do is actually return a value. So this is a function that returns a value 42. You might wonder, where does that return value go? Well, the operating system created main, so the operating system is actually going to, the operating system is called main, so it's going to get the value 42 back. So if we compile this thing, remembering we want it to be statically linked, and let's say rather than a.out, we will use -o test. So double checking the type of this thing. It's a statically linked elf MIPS32 executable. Sounds good. So we try running that MIPS and test, and nothing in particular happens. But if we look at the return value, so this special exit code called $, which was the result of the last command, then we get 42. So something's worked, yay. If you're wondering more about these exit codes, well, it is actually covered in I don't know, the man page is installed. It's a general convention that if you call exit in a program, or if you return from main, it will be bubbled all the way back to the person who called it. And 0 is generally considered to be success. So let's have a look at that. The program that the thing actually created. I'll use objdump. So objdump can do lots of things. I will use disassemble, and I will it's statically linked, so there's huge amounts of code. So let's get just the assembly. So test.c, I want test.s, and I want to assemble it. So now I can look at test.s, and just like before, we've got the text section. We say that main is globally exposed. We have the main entry point. There's really not very much in this thing. So here is the first instruction, which is fiddling with the stack pointer. It sort of remembers the stack pointer. It loads some stuff. I mean, here's a thing where we load immediate. We put 42 in register 2. There's this other stuff here. So how much of this do we actually need? So let's, well, just for completeness sake, let's check that we can actually assemble this. So we want to link this into something called test again. So we've ended up with file test. Let's try objdump in not the statically linked version. Let's try that. Note that this won't run in QEMU, but I just want to look at what's in it. So if I pipe it through less. So I have the init section, start, halt, deregister. Somewhere there should be a main. Maybe there's a main. Here's our main. So this is the section or the exposed thing called main, and it contains something that decrements stack pointer by 8, stores the stack pointer, stores register 8, moves the stack pointer in. Oh, S8 is one of these temporary things. One of the stack preserved things, I should say. Loads V0, which is a return thing with 42, which is what we want to do. Brings the stack pointer back out of S8. Loads S8. Fiddles with the stack pointer. So that actually restores the stack pointer to where it was. Jumps to a register and then does nothing. So if we try running that, I need to statically link it again. So we've got our statically linked thing. QEMU MIPS test echo. So we got our 42. So let's try cutting this thing down. So I'll do this incrementally, and what I'm going to do is check each time whether I need all of this stuff. So file, I'm guessing I don't need that. Don't think I need this. Probably don't need this. Do I need this? Maybe. No. Maybe. Let's try getting rid of this. Let's try getting rid of this, because I'm going for as small a program as possible. So I've edited that down. I'll try assembling it again. Missing.end end of assembly. Wow. Okay. Let's say keep it happy. Which should probably be there. End directive. No, I do not care. So it seems that it is actually updating this thing. So if I look at the timestamps, 1959 and test.s is also 1959. So let's try running this thing. It ran, and we get 42. So clearly this thing is still working, and I can verify that by going in and let's change it to 43 for some excitement. Run it and check the output. 43, excellent. So how much else of this do I actually need? Do I need to do anything with the stack pointer? Do I need to do anything with the frame pointer? So, well, let's try taking them out. So all this stuff with the frame pointer, I'm going to back this file up first, just in case. So I now have working.test.s as well. Oops, didn't want move, I wanted copy. So let's say copy to, that's better. So I'm going to try taking out some of these things. So do I need this stuff? Let us try. Well, no. Let's work out what it does first. So this decrements the stack pointer by 8. This restores it. So SP is going to be the same on exit as it was on entrance. Store word is going to take the frame pointer and store it at the stack pointer with offset 4. So that's going to put it in one of the two D words, the two 4-byte words that this thing created. This is going to take the stack pointer and move it into the frame pointer. This is going to take the frame pointer and move it into the stack pointer, which seems kind of pointless. So let's try getting rid of these things. So don't need that, don't need that, don't need that because it's reversed by that, don't need that, don't need that, I think. So let's try that. Compile it. Yep. Still whinging. And 43. So we're creating a progressively smaller thing that actually does just what we want. Of these things, I don't know, they don't seem to be causing any harm. .ent, I think that means entry point. We definitely need the .global because otherwise it won't link. I don't know if we need this, but it doesn't seem to hurt. So this seems like a pretty minimal thing. So this is a working thing. We could now say, can we do some maths in here? You know enough about writing MIPS programs. I could say something like add IU to $8. So if I find a MIPS temporary thing, one of the temporaries we have is $8. Let's call it $T0. T0 using register 0, 5. I can do add of $T0 and I don't know, $T0. It's kind of pointless. And then let's return this. I don't want the load immediate anymore. I'm just going to move $v0, I think, is the return thing. So v0 is the first argument out, first thing out. $t0. So hopefully this is now a function that's going to put the value 5 into the register t0. It's going to add 5 to 5 and it's going to return 10. 10. Awesome.